Lesson 5.6, Inverse of a function. Our essential question. How do you find and verify the inverse of a nonlinear function? There were 2 problems left for independent practice. Let's go ahead and take a closer look at these. So first we're being asked to consider this function. Because it has an exponent of a 3, we know that it is a cubic and that all cubics end up looking something like this. And this cubic is going to be vertically stretched and it's going to be moved down too. So it's still going to look this general shape. Now I need to determine, does this pass the horizontal line test? Anywhere I draw a horizontal line, will it pass this line twice? It does not, so this does pass the horizontal line test. And since it passes the horizontal line test, that means that the inverse, when we graph it, is going to be a function. So consider the function, we did. Determine whether it's an inverse, we did. Now it wants us to find that inverse. So let's go ahead and find the inverse. To find the inverse of this function, I need to write this function not with an f and x, with a y. So here's me writing the function with a y. And then we have to switch the x and the y's. And I need to solve for y. So I'm going to add 2 to each side. Divide both sides by 3. Now I need to solve for y, which means this exponent needs to go away. The only way to make an exponent go away is to raise it to another exponent so that when those 2 exponents multiply together, they will 1 each other out. 3 times 1/3 will multiply together to give me 1. So each side is getting raised to the 1/3 power. The 1/3 power is the same thing as the third root. So this is the third root of the entire fraction, x plus 2 all over 3. 3 times 1/3 is 1, so these 1 each other out, so I'm left with y. So my g of x inverse function is the third root of x plus 2 all over 3. Now I need to graph this inverse. I don't know how to graph third root functions like this, so we are going to use an xy table to graph this. So we're going to use a couple of negative points and a couple of positive points so we can see the general shape of what is going on. So I'm going to plug -3 into this g of x function because we're trying to graph g of x. -3 into this g of x function, I get -0.6. -2 into this g of x function, I get 0. -1 into this g of x function, I get 0.6. 0 into this g of x function, I get 0.8. 1 into this function, I get a 1. Typing 2 into this function, I get 1.1. Typing 3 into this function, it gives me a 1.18. So I see it is gradually going up. So let's go ahead and graph this. So -3, -0.6, -2, 0, -1, 0.6, 0, 0.8, 1, 1, 2, 1.1, 3, 1.18. So I see the general shape, and this is about what the graph is going to end up looking like. This is the graph of my g of x function. Okay, so let's go ahead and do our last problem. We're supposed to consider this function. Because this has an exponent of a 3, we know this is a cubic function, and all cubic functions look aboutish like this. Does this pass the horizontal line test? If I were to graph a line anywhere in here, will it pass it more than once? It does not, which means this does pass the horizontal line test. And if it passes the horizontal line test, that means the inverse, when I graph it, will be a function. So consider the function, I did. Determine whether the function's an inverse, I did. Now actually find the inverse. So let's go ahead and find the inverse. If this is the f of x function, instead of f of x, it needs to say y. And then I need to switch my x's and my y's. So I have x equals, in parentheses, y minus 3 to the 3rd power. So now my job is to solve for y. I can't get into the parentheses because this exponent of a 3 is blocking me. To get rid of an exponent, you need to raise your exponent to another exponent. When you multiply these 2 exponents together, they need to 1 each other out. Since this is a 3, we must be raising to the 1/3 power. So this is the third root of x equaling 3 times 1/3 multiplied to 1. They want each other out. I have y minus 3. We're going to add 3 to each side. So I have the third root of x plus 3 equaling y. So my inverse function g of x is the third root of x plus 3. Well, now I need to graph the inverse, the g of x. And we are going to graph it by using a table. We're going to pick some points on the left, some negative x values, and some positive x values. So plugging x into this g of x function, I get 1.5. Plugging negative 2 into this function, I get 1.7. Negative 1 into this function, I get 2. 0 into this function, I get 3. 1 into this function, I get 4. 2 into this function, I get 4.2. 3 into this function, I get 4.4. So this is our general graph. So let's go ahead and graph it. Negative 3, 1.5. Negative 2, 1.7. Negative 1, 2, 0, 3, 1, 4, 2, 4.2, 3, 4.4. I see my graph does this general shape. And this is my g of x function.